Good day, my angels. Today we want to be talking about scientific notation, which you've probably seen before, but I'm going to be a little fussy. I'm going to insist that you do this a certain way on your calculator. Now, the good news is the way I'm going to encourage you to encourage is not strong enough a word. The way I'm going to make you do this on your calculator is the laziest, shortest, least amount of typing way to do it. It'll also guarantee that you won't get weird, obscure math errors later on when we get into way more complicated calculations. We have to deal with some really big and really small numbers in physics. More so in physics 12. We won't use scientific notation an awful lot in physics 11. We will use it an awful lot in physics 12 because we want to use the numbers that the universe has given us, and some of them are really big or really small. So I wrote here, during this course, we're going to use models, often mathematical, to help us understand a particular set of phenomena. If you are a strong math student, you will find that I teach things very mathematically. You're going to hear me say over and over and over again, don't memorize this. I'll teach you how to derive it. If you're not a strong math student, take heart. You'll become a better math student, I believe, because of taking physics. Time and time again, I've had kids come into this course who have said, yeah, not great at math, and all of them have told me by the end of the year, holy smokes, Mr. Dewick, this actually helped me in my math class as well. So I will nudge you to become good. Sorry, nudge is not strong enough a word. I will blatantly put you on the edge of a cliff and then push you over with both hands as hard as I can to become a much better math student. In fact, you're going to find, Sophia, that I'm going to encourage you to do stuff in your head fairly often in our homework. On a test or a quiz, Mason, I'll always show my work, but I will nudge you in your homework. Can you do it in your head and go straight to the answer? I'm not taking marks off for that. That's becoming an expert. That's kind of how I do it when I'm in a rush and doing it for my homework. So we will really push ourselves. So I wrote here, we're going to use models, often mathematical models, to help us understand a particular set of phenomena, to help us figure something out. I need to point out, though, that this course is one big lie. The models that we use will almost always be wrong. I will ignore friction. I will ignore air resistance. I will make up fake forces that technically don't exist, but they help us do the math much better, so we'll pretend that they exist. The answer to everything is quantum physics, and you can dive down to that level every single time, Caden. If you want to, we're not going to. We're going to stay at a much higher level and just work with what we have. And they will be good approximations. If we ignore air resistance, you know what? As long as what we're dropping is a bowling ball, which is pretty aerodynamic, nice and round and heavy, we'll be pretty close. Oh, if we're dropping a piece of paper, all the physics that I'm teaching you is going to be garbage. Sorry. Since our models will be mathematical, good math skills help. I often say to kids in grade 10, if you got an A or a B in math 10, physics 11 is an easy B and a pretty doable A. But I also say that physics helps you become better at math. One math skill is scientific notation. So what is scientific notation? A couple of rules for a number that is correctly written in scientific notation. There can be only one digit to the left of the decimal point. So 12.3 times 10 to the fourth is or isn't in scientific notation. Donald is shaking his head, so is not. How would I write that in scientific notation? Well, the front part would look like this, 1.23 times 10 to the fifth. And some people will have an intuitive sense for moving the decimals around and seeing how it affects the powers of 10, but some people will need to count, and that's also fine. Yeah, basically, I've moved the decimal point 1 over, and I can do that by adding a power of 10. Step 2, you count the number of decimal places, the decimal point moves. If the decimal point moves to the left, the power of 10 will be positive. My abbreviation, I tend to abbreviate. My abbreviation for the word positive is a plus sign followed by a VE. You know what my abbreviation for the word negative is? It's a minus sign followed by the letters VE. Why do I put the VE there? As a math nerd, if I just see a plus sign, I go looking for the rest of an equation. I don't realize that you mean the word positive, so my abbrev that I came up with is that. That lets me know, oh, this is the word positive. I'm not missing an equation somewhere. Figure out your own system of abbreviations and use it. If the decimal point moves to the right, the power of 10 will be negative. And I wrote here in bold font with asterisks, it's really important to figure out how your specific calculator handles scientific notation. Here is what we are never going to do. If I wanted to type 1.23 times 10 to the fifth, don't write this down, we are never going to type 1.23, and then we are never going to hit our times button. We are never going to type a 1. We are never going to type a 0. We are never going to type our exponent button and then a 5. We are never going to do it that way. That is way too much typing, and it will introduce errors later on. First of all, you have to be able to rewrite something in scientific notation. So the Earth weighs that much. That is accurate. Could I even type that into my calculator, Hannah? No. Oh, that's a lie. I have a pretty fancy schmancy TI graphing calculator interface, and so I've got an unlimited amount of space. I could type this number into my calculator, but most calculators only have a 9 or 10 digit display. So one of the reasons we need to get good at scientific notation is to enter data. How would I write this in scientific notation? Well, I think the first thing that I would do is I would realize that I'm going to be moving the decimal point from right there to right there. So it's going to be 5.98 times 10. And then I have to count. How many spots have I moved the decimal point? Count on your own. I find it easier to do little loops. I'm getting something in the 20s. What'd you get? 24? Yes? The Earth does weigh just under 6 times 10 to the 24 kilograms, 5.98 times 10 to the 24 kilograms. Mr. Dewick, how did they figure that out? It's not like they could put the Earth on a scale. We'll actually calculate it in Physics 12. I'll show you how we figured it out. That's called a teaser, a preview of coming attractions, for those of you who are wondering. Okay. One proton has a charge of that. How will I write that in scientific notation? Well, the decimal is going to move from there right to there. So the beginning part going to be 1.6 or 6.1? 1.6, we go in the same order, okay? 1.6 times 10 to the... How do I show that this is a small number less than 1 with my exponent? Negative. I always put the negative in right away because I can't tell you how many times I've forgotten to put the negative in after I counted. And again, now I count. I'm going to zoom in because I could hardly count before. You get something in the teens. Negative 19. And then charge is measured in coulombs. Yeah, that's called actually the elementary charge of the universe, 1.6 times 10 to negative 19. We don't look at this electricity in Physics 11. We look at it much more in Physics 12. Oh, by the way, the charge on an electron is negative 1.6 times 10 to negative 19 coulombs. That's why we say they have the same magnitude of charge. The temperature of the sun is 15 million degrees Kelvin. What? Oh, 15 million degrees Kelvin. Okay, 15 million. Well, 15, how many zeros makes a million? What would that be? 15 what? Thousand? Oh, there's my million. This one I kind of counted along as I was adding the zeros. So it's going to be 1.5 times 10 to the... One of those answers is correct. The good news, yes, the number does start with an S. 6 or 7. Let's see. Decimals moving from there to there. And I'm glad someone said 6, because the most common sloppy mistake we make is we count the zeros. That's not scientific notation. You count the number of decimal place movements. And then degrees. Okay. So that's going from what we call standard form to scientific notation. By the way, I will show you, if you wish, how for numbers that you can type onto your calculator, you can toggle scientific notation on and off. All of you can do that on your calculator. And so later on, when you're working on the homework, if you want me to do a mini tutorial with you on how to make your calculator sing, I can do that. Even yours might be able to, maybe Braden, you might be the exception, because I'm sorry, your calculator really is a POS. I apologize, but it is. But the rest of us that have good ones, we can probably muck around with the modes and the settings to set it up any way that we want. So going from standard form to scientific notation, or going from scientific notation to standard form. So if I get 5.4 times 10 to negative 7, what is that if I have to write it out? Well, it's a negative as the exponent, so it's going to be less than 1. So I would start out, Caden, by going 0 point or point. I'm not fussy if you put the 0 in front of the decimal point or not. Apparently, I flip-flop. What's the exponent? Negative what? Most common mistake is kids think that's 7 zeros. It is not 7 zeros. It's 7 decimal places. And one of the decimal places is going to be used up by that 5. So it's going to be how many zeros? 6. 1, 2, 3, 4, 5, 6, and then a 5, and then a 4. Oh, and then units, meters. You should know I'm really, really fussy on units. If you don't write units in your final answer, I will always take off a half mark. I don't write units during my work, but one of the things you'll develop the habit of, Hannah, is whenever you hand in a test or a quiz, before you hand it in, you'll do a quick double check. Did I put units and everything? Because Mr. Dewick will mock me mercilessly if I don't. I will. 4.23 times 10 to the third. What's a capital J? Joules. What does it measure? Work and energy. So some of you did a little of that in Science 10 last year. Okay. We'll be doing way more of that, I hope, this year. That's one unit I hope to get to near the end. Okay. 4. Again, common mistake, kids see the 3 and they think 3 zeros. No, 3 decimal places. The 2 uses up 1 place. The 3 uses up 1 place. And I guess I have to add 1 more 0. That's 4.23 times 10 to the third joules. And now we get to the slightly painful part. I'm going to be walking around and showing you how to use your calculator. How do you type 6.23 times 10 to the negative 5? Here's what you do. Put calculator down, Edward. Patience. Can all of you write in your notes 6 with a box around it, because that's a button that you will hit. Decimal, because you'll hit that. 2, because you'll hit that. 3, because you'll hit that. Here's what you won't type: a times or a 10 or a to the power of. So if you have a Casio, probably bottom row middle, you either have a button labeled EXP or you have a button labeled times 10 to the. That's going to be your scientific notation button. If you have a TI, you have a button labeled EE, and it may be a second function button. It's often second function kind of in this area if you have a graphing calculator. If you have a sharp, It may be an EXP button again, or it may be a times 10 to the button. Here is what it is not. It is not. You also have that button there. That's something different. So what I would like you to do is try and identify your scientific notation button, and I'm going to come around and confirm that that's it. What you will do right here, you will draw whatever your button is. For me, on my TI, it's the EE button, and I know it's, for me, second function comma, because I've got a fancy schmancy graphing calculator. Third thing, please notice there is a difference on your calculator between minus and negative. So you'll need to use your negative button, and a negative will actually look different on your screen from a subtraction sign. So negative, and then hit the 5. Now, on my calculator and on the TIs, when I type this in, let's go like this, Mr. Dewick, 6.23 scientific notation, negative 5. When I hit my scientific notation button, can you see I get an uppercase E but shrunken down? That's how computers used to do scientific notation, and TI, who also used to make computers, adopted that notation for their calculators. On Edward's calculator, his actually, when he hits that button, types in the times and the 10 and to the power of for him. Some of yours will do that. Some calculators will do an EXP, actually type that out. Did I cover all of them, or is there somebody else's whose calculator showed something? Oh, yes. Yours is probably so cheap that it just leaves a space and it puts the negative 5 off to the right with a space in between your number, and it expects you to clue in that that's what it's doing. Am I correct on that one? Okay. Then, once you've typed that in, to store that number, just hit equals. And again now, different things will be happening. My calculator, I have it set up so that if a number is below a certain number of decimal places, it will automatically, Hannah, give it to me in scientific notation. Your calculator might actually have gone 0.00000623. Some of your calculators might be showing that on your screen right now. I don't know. It's going to be how you have your calculator configured. Why am I being so fussy? If you use your scientific notation button, your calculator software knows that this 6.23 and this times 10 to the negative 5 are attached and are one number. If you don't use your scientific notation button, it will not know that. In fact, it will assume they are not attached, and you'll get weird errors when you try and multiply and divide. The powers of 10 might not behave the way you're expecting. Anybody couldn't get that to work so far? So let's just try some math with scientific notation. So turn the page, or next page. I think it's turn the page. Yeah, it is. You ready? First thing I would ask always for number 1 is this a fraction? Be obvious. Is this a fraction? Yes. Okay. Is there more than one thing on the top? I'm going to need brackets around the top. Don't start typing yet. Is there more than one thing on the bottom? I'm going to need brackets around the bottom. Unless, if you have one of the newer Casios, you might have a button that looks like that, and it'll be sitting right around here in the upper left corner, third or fourth button down. If you have that, anytime you see a fraction, hit that button. That actually gives, because your screen has a 2-level display, and you can actually type stuff on the top and type stuff on the bottom, and you've just saved yourself a whole bunch of brackets and typing and nonsense. The rest of us, peasants, will have to actually use brackets. That's number 1. Now, number 2, don't start typing yet. When I handwrite or when I type, brackets make things clearer to show multiplying. Two brackets side by side, Kai, mean multiplying. When I type in my calculator, brackets make things way, 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 way more confusing. So I try and use as few brackets as possible. So you're going to follow along with me key by key. Get your calculator out. Those of you with the fancy schmancy fraction button, hit that and then make sure you're on the top. The rest of us, we will open a bracket up. You have brackets, Braden, on yours, but again, you can't see the bracket the way we can. Are you starting to see why I ragged you a little bit? It's going to be a little frustrating. It can be done, but you're going to have to keep track of a lot more. The first number is 1.8.
Wait, if I have the fraction thing, I don't need the bracket.
Show me your calculator, please. Yes, that's correct. If you have the fraction button, you don't need to open up with a bracket because your calculator implies a bracket with that top little square. It's saying this is all one thing already. I typed 1.8. Am I going to hit times and 10 and to the power? No, 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 no. Scientific notation button. Oh, wrong button. Scientific notation button. -3. Some of you might be up inside a little tiny exponent. If you are, you might have to go right arrow or down arrow to get back to ground level. Possibly some of the newer Casios have that. Here's what I would not do. You notice how when I type this for you, there is a bracket closing things off right here. The problem is if I do this, I've just told the software on my calculator that's where the top ends. Does the top end there? Instead, to show two brackets side by side, which means multiply, all of you hit your times sign. On my TI, the times sign is the asterisk because that's what it is on a computer, and it's continuing with the computer notation. Some of you might have an actual little X timesy signy thing. 2.6. Scientific notation button. 5. Caleb, have I reached the end of the top?
Say yes.
Yes. For me, close bracket to close off the top. For those of you with the fancy schmancy 2-level fraction, down arrow. For those of us that don't have the fancy schmancy fraction button, I have to hit divided by. I kind of like my TI. It does a slash for divided by, which I much prefer. I find this symbol from a distance when I'm far away from the back of the room, I can't tell whether that's a plus sign or a divided by because it kind of looks like both. So you'll never ever see me write this symbol. I will always show my dividing with a big fraction bar actually, because then you can clearly see what's on the top and what's on the bottom. Xavier, is there more than one thing on the bottom?
Say yes.
I have to open up a bracket. Those of you with the fancy schmancy button don't. 9. Am I going to hit times? Am I going to hit 10? Am I going to hit to the power of? No. I'm going to hit my scientific notation button, which contains all three of those. It's a good time saver. 8. Times. Not going to hit bracket, because again, if I close this bracket off right now, if I put a bracket there, I've just told my calculator the bottom ends there. Does the bottom end there? No. Times 1.3, scientific notation button, -1, and then I have to close off the bottom with a close bracket. If you've typed this incorrectly, when you hit equals, you should either get 4 times 10 to the -6, or your calculator might display it as 0.000004. If you didn't get that, don't hit clear. Just raise your hand and I'll come look at your calculator. This is how we roll today. So, what did I do? Well, I did that, and I know that my calculator displays 4 times 10 to the negative 6 as 4e negative 6. I'll never write that as my answer. As my answer, I would say, oh, that's 4 times 10 to the negative 6. Okay. Yeah, I can cut and paste calculator work in here too, and I'll do that sometimes. We are going to be typing in far longer fraction-y things than this, not right away, but by the end of this course, and certainly next year when we look at orbital mechanics, it's rocket science. It's not meant to be easy, and the numbers involved in rocket science, unfortunately, our universe just didn't give us nice, convenient, nice numbers. One of the numbers you type in all the time, anytime you're dealing with gravity, is 6.67 times 10 to the negative 11, which just gives you long fraction-y, decimal-y answers all the time. So it is what it is. Here, let's try the second one together. I would clear my calculator. I would then say to myself, self, is this a fraction? Is it a fraction? Is there more than one thing on the top? Yes, brackets around the top. Or fancy schmancy fraction buttons. So I would open up a bracket. 5.8. Am I going to hit times? Am I going to hit 10 to that? Am I going to do another bracket? No, no, and no. I'm just going to hit my scientific notation button. 3. Am I going to close off the bracket? No, 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 no. Is that a headphone in you? Could you take that earbud out of your ear, Caleb? Thank you. Or next time I'll put it somewhere else. Thank you. 2 brackets side by side means multiply. Well, times 2.67 scientific notation 21, close off the top, divided by bracket negative, which is different from subtract. Most of you will either have your negative button in the bottom row right next to the equal sign, or it might be above or next to the number 7. That seems to be the 2 most common places. So mine is right here, negative 9.24, scientific notation button, negative 3, times button, 1.3, scientific notation, negative 1, close off the bottom. This is going to be a pretty big answer, or pretty small, I can't remember. Yeah. I got negative 1.28921. Yes. Oh, I'm sorry. My mistake. No, no, no. You caught that. I made a dumb mistake. You get a candy. Okay. So, let me go like this. Divided by, and I open up my bracket. Okay. Now, here's the nice thing. If you're using your scientific notation button, Edward, are you using your scientific notation button?
Sure, yeah.
Then I don't need to put the scientific notation-y thing in brackets. If I stick an exponent afterwards, my software will know that the exponent goes on the 10 to the and on the negative 9.24. So I go like this, negative 9.24, scientific notation, negative 3. And now I need to find where my to the power of button is. Look up, everybody. Many of you will have an exponent button that looks like this. It's the second function 6 on your calculator, on your keyboard. It's a carré. So that's what many of you will have. Mine looks like that. Some of you will have a button that looks like that. Some of you will have a button that looks like this. Some of you will have a button that looks like that. You will not hit that button because that's your scientific notation button. That doesn't mean exponent. That's actually an abbreviation for scientific notation, exponential notation. So now, again, try and find your exponent button. If you can't, raise your... Thank you for pointing out my dumb mistake. So 5 is my exponent. And then I can go times 1.3 scientific notation, negative 1, close off the top. And you should get, now that I've typed this in properly, I think negative 1.76862617 times 10 to the 36. Mr. Dueck? Yes, Alicia? What do we round this off to? Our next lesson will be the rules in science for rounding off. It's called significant figures, and we'll talk about that next. But for now, pick a nice place to round off, but round off properly. Round off, don't chop off. If you told me this was negative 1.7, I'd take a half mark off. I would probably go to 3 or 4 decimal places. Somebody was raising a hand. Yeah. Okay, hold your screen for a second. How many of you were able to get that? Can you raise your hand? So most of you. Okay, so I'm going to write out the answer first of all. Let me erase all this gunk. Oh, and let me do my clever boom. Equals negative 1.76. I'll go right to there. 9 times 10 to the 36. And then pause for just a second while I help others. Look up for a second. You'll notice I've been yelling at you in love to say, hey, don't put those brackets in there. Don't put those brackets. Don't put those brackets. Use a times sign. And I'll show you why. I would argue, let's look at the first example that we did. Sorry, let's go like this. The first example was that one there, okay? If I were to type that with all the brackets in place, it would look like this. I would open up a bracket for the top. I would open up a bracket for the 1.8. I would go 1.8. I would go scientific notation button -3. I would close off a bracket. I would open up a bracket. I would go 2.6 scientific notation button 5. I would close off that bracket. I would close off the top. I would go divided by. I would open up a bracket for the bottom. I would go 9 times 10 to the 8th. I would close off the 9 times 10 to the 8th. I would say, oh, wait a minute. I needed to have 2 open brackets at the bottom because I had to open up the bottom and open up the 9 times 10 to the 8th. 9 times 10 to the 8th. I would close off the 9 times 10 to the 8th. I would open up a bracket there. I would go 1.3. I would go times 10 to the -1. Close off that bracket. Close off the bottom. I'll get the same answer, but I would argue that top one, it's way easier to see. That's the top. That's the bottom. Here, that's just way, way harder to read. It's more typing, which introduces more chance of typos, for being less easy to read. To me, that's a triple no-no. So I would encourage you to just get used to realizing, Mason, we're going to handwrite fractions with brackets because when handwriting, it makes it clear, or typing. But on your calculator, I use times to show times. I use brackets to show multiplication. When I handwrite, I use the times sign to show multiplication on my calculator. Is that okay? Okay. We're going to jump to the homework just a little bit, but put your pencils down and look up.